All right, so these are the notes for solving quadratic equations by square roots. So the first thing I do is make sure that your equation is in the form x squared is equal to a. After this, a couple things about a must be positive. So in order for you to solve it, a must be positive. Then you're going to isolate the x squared, and once you take the square root of both sides, then a is going to have solutions. There will always be two solutions, okay? So you're going to isolate x squared, take the square root of both sides, and then you'll get two solutions, a positive and a negative. So right here, once you take the square root, you put a plus or minus in front, which gives you a positive square root of a and a negative square root of a. So those are your two solutions. All right, so let's go ahead and take a look right here. Solve the following equations for x. So for this first one here, we're going to isolate x squared. So first we're going to undo the 7. And actually what I usually do is you do PEMDAS backwards when you're solving. So you're going to do SADMAP. Okay, so you do addition or subtraction first. So I have this negative 7, so I'm going to add 7 to both sides. And that's going to give me x squared is equal to 36. Then you do multiplication or division. In this case, x squared is isolated. So now we're going to go to the exponent. So to undo this squared, we take the square root of both sides. And once you take the square root, you immediately put plus or minus. Okay. So the inverse of the square is the square root, so they're going to cancel each other out, leaving you with x. And over here, we have the square root of 36, and the square root of 36 is 6. So we have plus or minus 6. And that is my solution there. And you can always double check it by taking this and plugging it back in here. Like 6 squared is 36, minus 7 is 29. Negative 6 squared is 36, minus 7 is 29. So you can always double check your answers like that. All right, for the second one, same thing. We're going to start with addition or subtraction first. So I see a positive 5. So we're going to subtract 5 to the other side. And then we come up with 3x squared is equal to 41 minus 5 is 36. Next, we're going to do division or multiplication. So in this case, we have 3 times x squared. So we undo this by dividing by 3. And that comes up with x squared is equal to 12. And now we're going to get rid of the exponent. So to undo a square, we take the square root of both sides. Once again, don't forget to put plus or minus. And then we get x equals plus or minus the square root of 12. Now, since we just talked about this, we're going to try to simplify this radical. So I'm going to do this right over here in blue. So I'm going to start with 12. The smallest prime factor that fits into 12 is 2, 6 times. The smallest prime factor that fits into 6 is 2, 3 times. And the smallest factor that fits into 3 is 3, 1 time. So hopefully you can see we have a pair of 2's. So that goes on the outside of the radical. And back inside is 3 times 1, which is 3. So we now know that the square root of 12 simplifies to 2 radical 3. So my final answer will be written as x equals plus or minus 2 square root of 3. And now we're down to the last problem. It says 3 times the square, 3 times parentheses x minus 2 parentheses squared equals 24. So the first thing we do here is there is no addition or subtraction. But I do have this 3 that I can remove, so I'm going to do it by dividing both sides by 3. And that leaves me with parentheses x minus 2 squared is equal to 8. Right here, we're going to get rid of the square, so we're at the exponents already. We're going to get rid of the square by taking the square root of both sides, immediately put plus or minus. Then we come up with x minus 2 equals plus or minus the square root of 8. Now, before we go any further, the square root of 8, we're going to simplify that. So I'm going to take 8. 2 goes into 8 4 times. 2 goes into 4 twice. And 2 goes into itself once. So I can see I have a pair of 2's here. So 1 pair outside, so that's a pair of 2's. And 2 times 1 inside is 2. So this actually now becomes x minus 2 equals plus or minus 2 square root of 2. My last step to isolate x is to remove this minus 2, so we're going to add 2 to both sides. Be careful, we cannot add these 2 together, because this is not, this is just a 2, but this is 2 square root of 2. They're being multiplied together, so we can't actually add these together. So I like to write it, I put the 2 in the front, so 2 plus or minus 2 square root of 2. And again, you do have two answers. And you could always rewrite this as 2 plus 2 square root of 2 or 2 minus 2 square root of 2. And this actually becomes important when you have like just like 2 plus 2 is 4 and 2 minus 2 is 0, like things like that. But in this case, these answers would be final because of the radical sign. All right, and that concludes the notes.